Dark matter and dark energy explain simply there's something extraordinary that we have discovered about universe. The ordinary matter and energy that we experience in everyday life makes up less than 4% of what's out there. Dark matter makes up about 21% of the known universe, and dark energy makes up 74% of we know little about dark matter and dark energy. Hence word dot being used to describe both in this video. I am going to tell what we do so far. Dark matter. It is a form of matter that doesn't interact with light and so it's invisible to us. We know is there because calculations have shown that without its gravitational pull, galaxies and other structures in the universe wouldn't have been able to form dark matter. It's also required to explain the motion of galaxies. It explains why stars and gas clouds on the outskirts of a galaxy as fast as they do. Einstein described space-time continuum as the fabric of the cosmos. Space-time incorporates the three dimensions of space, up and down, left and right, and back and forth, and the fourth dimension of time. Einstein thought of space-time as malleable. Mass and energy can wrap space-time, and this gives rise to the phenomena of gravity. Dark matter does have mass and therefore produces gravity. Where there are large clumps of dark matter destroys the light coming from galaxies behind. This distortion effect is called gravitational lensing. We have been on hunt for dark matter for decades, and the general consensus among cosmologists is that it may be made up of an exotic subatomic particle that we have yet to detect dark energy. In 1929, astronomer Edwin Hubble discovered that explains the universe. The further away an object is from the Earth, the redder it appears as the wavelengths of its light coming towards us stretch. The electromagnetic spectrum is the entire range of light that exists from radio waves to gamma rays. Visible light is electromagnetic radiation within the electromagnetic spectrum that can be perceived by the many. Example, longer wavelength correspond a shift towards the red end of the electromagnetic spectrum. Hubble noticed that the further away a galaxy was, the more redshifted it became, and after a detailed analysis of different redshifts, he concluded that the galaxies were flying away from each other and the universe was growing in size up. Until the late 90s, signed that his thoughts that the expansion of the universe would either slow down or even contract, owing to the effects